Hi, this video will cover section 1.6, solving quadratic equations with the quadratic formula. And this video is for the class Math 0305, the core requisite of Math 1324. Now, we're going to start by filling in the blank. So we have the first statement, a quadratic equation in one variable. One variable is an equation that can be written in this form: ax squared plus bx plus c equals 0. And or actually, we will equal it to 0 when we're trying to find the solutions, but right here we could just say that it equals to the dependent variable, which we could use y, or we could also give it a function name and just use f of x. So let's see what a, b, and c will represent. So a will always be the coefficient, the number of the x squared. B will be the number part or the coefficient of our x term, the big number that goes in front of it. And c will be the constant term, the numerical part of your quadratic equation. So we have here that a, b, and c are constants or numbers, we could say, and x will be the variable that we will be solving for. Now, this booklet contains problems where the variable that we will be solving for will not always be x, like in this case here, we will be solving for y. We're going to use the same steps, write the coefficients, write the numerical terms, and then for this section, we're going to concentrate on the quadratic formula. So let's write that one next, and it says a quadratic equation written in the form ax squared plus bx plus c equals 0 has solutions where a cannot equal 0. And that's very important because if the coefficient of the x squared term was a 0, then we wouldn't be talking about a quadratic equation. So we have to make sure that the x squared exists there so that we could still call it a quadratic equation and solve for it with the quadratic formula. So let's write that one down, and that will be x is equal to negative b plus minus the square root of b squared minus 4ac, and everything gets divided by 2 times a. So now the letters that you see here, for example, remember we said that a was the coefficient of the x squared, so we're going to substitute that with the numerical value of the coefficient. Then b is the coefficient of the x term, and so that one will get substituted here and here. And then finally we have c, which is the constant term, and that will go 1 time in here. Now, it's very important that we still keep those signs just like they are written here. We need a negative here, and then we also need a negative here. Now, this plus minus, that indicates that you have 2 solutions. One will be found using the plus sign, and the other one using the negative sign. And you will see that when we do the examples. So we also have to follow order of operations, and so that's what I'm going to be doing throughout this video. So we start with example 1a, and the first thing that I recommend, in fact, if you are my student, you must do this. You need to write down what the coefficients and the constant term will be. So a is equal to 5, b is equal to not 14, but negative 14. And this is a huge mistake that students do sometimes. Instead of writing them down, they just say a, b, and c. If you get used to doing that, you might happen to overlook that b is negative and not positive. And so if you ignore that, then your solution will be completely wrong. Now, for the constant term, which is c, it will be negative 3. Okay, so now I'm going to write every time I use the quadratic formula, I write it down just to make sure that I do my substitution correctly. And so if you do this, it will also help you memorize it. Remember, not all teachers will allow you to use the quadratic formula. Okay, so now I'm going to start substituting with the variables that I have. And so remember, the a equals 5. In fact, the number 5 will be replaced here and here. And then we will be replacing the numerical value for b, negative 14, in here and here. And then finally, we will do the same for negative 3, the value for c, and that will be replaced or substituted once. So I'm going to start substituting and write down the problem. Then we will solve it by hand, because in 0305 you're not allowed to use a calculator. So here the formula has a negative sign, and the numerical value for b is negative itself, so I'm going to put it in parentheses so that I don't forget to distribute the negative that comes from the formula. Then we need plus minus square root, then the value for b is negative 14. We're going to square that, and then minus 4 times a, which is 5, and then times c, which is negative 3. All of this is still inside the square root, and here we will have 2 times a, so 2 times 5. So moving on, this is going to be negative times negative. So that will give me a positive 14, or simply I just don't need to write a sign in front of it. And then we will have plus minus the square root. Then I'm going to square the negative 14. And this is very important that you put the negative inside parentheses. And so that will give us 196 positive. Then I'm going to multiply the negative 4 times the 5 and then times the negative 3. So that's going to give me a positive answer, and that will be positive 60. So all of that is divided by this part right here, 2 times 5, which is 10. Now, from here, I'm going to add the two numbers that are inside the radical, and that will be 256. All of that is divided by 10. Now, 256 happens to be a perfect square, meaning that we could take the square root of it, and that will be 16. Now, in this class, you are allowed to use a scientific calculator, and with that, you could have access to the square root function if you're not sure about the answer. So in this case, I'm still going to write it with the plus minus, and then at some point we're going to separate them. So the 16, that came from the square root of 256. Now, what I want you to realize is that we're going to have two solutions, so we're going to be splitting them. One of them is going to be calculated with the positive sign. And we have to do one at a time. So in this case, we will have x is equal to, first we add the numerator, that will be 20. I'm sorry, not 20. I was going to say 24, but no, it's 30 actually. 14 plus 16, it will be 30. So 30 divided by 10, and that will equal to positive 3. So that will be our first solution. Now, what I don't want you to do is to assume that because you have positive 3 that you have x equals negative 3. That's in fact a common mistake, and it's just not true. You have to work out the solution. So don't be lazy and just take the time to write it down, and you will see that it's not negative 3. So let's try that, and that will be 14. Now we're going to use the negative sign. So minus 16 divided by 10. So now x equals 14 minus 16 will be negative 2 divided by 10. And so negative 2 divided by 2 is negative 1, and 10 divided by 2 is 5. So the solution is negative 1/5. So you have two solutions. Sometimes you're asked to put them in ascending order, so starting from the smallest 1/5, and then it might say separate them with a comma. So that means that x could be either 3 or negative 1/5. Since those two numbers are real, we will see them as x-intercepts in the equation. Okay, now I'm going to move on to the next problem. And for that, I'm going to start by writing my A, B, and C numerical values. So for A, we have 1. That is the number here, the coefficient of the y square. B is equal to 5, and then C is equal to 3. So again, I'm going to go ahead and copy the formula, and you should do that as well. Negative b plus minus the square root of b squared minus 4ac. And all of that divided by 2 times a. Now here, x will equal to, now I'm going to start substituting negative from the formula. B is just positive, so negative 5, plus minus the square root of 5 square minus 4 times a, which is 1, and times c, which is 3. All of that divided by 2 times 1. So I'm going to solve what's inside the radical, which is the radicand. So 5 squared, that will be 25, and then the product of negative 4 times 1 times 3 will be negative 12. All of that is divided by 2. Now, again, we do what's inside the radical, so that will be 25 minus 12, and that will give us 13. So 13 does not have, it's not a perfect square, so it does not have an exact square root. And so what I'm going to do is just leave it like that with the 13 there. So in this, we still have to consider both cases, one with the plus and one with the minus. So in this case, we will have, again, two solutions. One of them will be negative 5 plus the square root of 13 divided by 2. And the other one is going to be x is equal to negative 5 minus the square root of 13 divided by 2. And sometimes if you want to, let's say, sometimes you're able to simplify, not the case with this one, but in the next example, we'll see that. It will be negative 5. Remember, the 2 divides everything, so it does divide the negative 5, and it also divides the coefficient right here of the square root of 13. Not that you can divide, for example, if you had the square root of 14, you cannot divide 14 by 2 because one is inside the square root and the other one isn't. So the other one will be negative 5 divided by 2, and then minus the square root of 13 divided by 2. So that is just the same two solutions written in a different way by splitting the fraction. Now I'm going to move on to the next page, and we do have several examples on that page, and they all have like something different about them. So we start here with example C, and I'm going to start by just, I'm going to write the quadratic formula again, negative b plus minus the square root of b squared minus 4ac, and all of that is divided by 2a. So now a is the coefficient of my x squared, which is 1/8. B is the coefficient of x, which is a 1, positive. And then finally c is negative 5/2. So now we're going to start substituting into the same quadratic equation. So for negative b, we'll have negative 1, then plus minus square root, and here we need b squared, so that will be 1 squared minus 4. And now we're going to multiply by 1/8. That's a. And then for c, we substitute that with negative 5/2. Now all of that is going to be divided by 2 times a, so it's 2 times 1/8. Okay, now I'm going to start simplifying. So to multiply fractions, well, let's do this first. So I'm going to have -1 and then plus, minus. We need the square root. 1 square is 1. And then the product of these fractions here, I'm going to perform that multiplication here on top of the page. So that's going to be -4 as an integer. It will be the same as -4 divided by 1. Then times 1 over 8, and then times -5 over 2. So what we do when we multiply fractions, we multiply it straight across like that. So -4 times 1 is -4. Then -4 times -5 will be positive 20. Then we multiply the denominators, and so that will be 1 times 8 is 8, times 2 is 16. And so that's what I'm going to use here. (20/16). All of that, let's not forget that we are multiplying by or dividing by the product of 2 times 1/8. And so again, if we multiply horizontally, we will get 2 divided by 8. So now I'm going to continue my work here. And now we have -1 plus minus the square root. Now, the problem with the radicand, the stuff inside the square root, is that we have an integer and we have a fraction. So if we have this number, 1 divided by 1, and we wanted to have a 16 as the denominator, it will be 16 divided by 16. And so that's what I'm going to write instead of the 1. 16 divided by 16, so that I can add it to the 20/16 that I have here. And all of that, let's not forget, we're dividing by 2/8. By the way, I'm going to simplify it into 1/4, because 2 can be divided by 2 and 8 can also be divided by 2. So we get that. And now here, this will be -1 plus minus the square root of 36 divided by 16 over 1/4. Now from here, we could say -1 plus minus, and this will be the square root of 36 divided by the square root of 16. Those two expressions are equivalent, and this is divided by 1/4. Now, if I take the square root of 36, it will be 6, and the square root of 16 will be 4. All of that divided by 1/4. So from here, if we want to turn this -1 into fourths, it will be -4/4. And so remember that from here, we have two solutions. One of them has to be found with the addition from the plus minus. And the other one will be found with the negative. So in this case, we will have -4 plus 6 from here. And that will give me 2/4 divided by 1/4. In this case, I'm going to multiply the numbers that are on the outside, such as the 2 and the 4. So that will be 8. And then the numbers on the inside, 4 times 1 is 4. And so if I divide that, I will get 2. So that is my first solution. The second solution will be found with -4/4. And now we use the -6/4. We use that because of the plus minus situation here. All of that, let's not forget that we're going to be dividing by 1/4. So in this case, we will have negative 10 over 4 divided by 1/4. And so that will be, if I multiply the outside numbers, it will be negative 40. And then the ones on the inside, it will be 4. And so that will be negative 10 as our answer. So our values for x, solutions, roots, zeros will be positive 2 and negative 10. And so I will stop this video right now, but I will be recording the second part sometime today. So thank you for watching.